Welcome back to my channel, where we dive deep into the world of software development and explore ways to write clean, efficient, and maintainable code. My name is Darina Zvetanova. I am an IT recruiter at IT Experts Europe. In today's video, we're going to discuss a crucial aspect of code quality: code smells. Code smells are indicators of potential issues in our codebase that could lead to reduced readability, maintainability, and performance. To combat these issues, we'll explore the art of refactoring, a disciplined process of improving the code without altering its external behavior. We'll cover 5 types of code smells: bloaters, object orientation abusers, change preventers, dispensables, and couplers. Let's get started. Bloaters are code methods and classes that have increased to such gargantuan proportions that they are hard to work with. Usually these smells do not crop up right away, rather they accumulate over time as the program evolves, and especially when nobody makes an effort to eradicate them. Let's look at long methods that are in this bloaters group. Like the Hotel California, something is always being added to a method, but nothing is ever taken out. Since it's easier to write code than to read it, this smell remains unnoticed until the method turns into an ugly, oversized beast. How to treat it? 1. To reduce the length of a method body, use extract method. 2. If local variables and parameters interfere with extracting a method, use replace temp with query, introduce parameter object, or preserve whole object. 3. If none of the previous recipes help, try moving the entire method to a separate object via replace method with method object. 4. Conditional operators and loops are a good clue that code can be moved to a separate method. For conditionals, use decompose conditional. If loops are in the way, try extract method. For these techniques, we will talk later in my next video. Primitive obsession. Use of primitives instead of small objects for simple tasks, such as currency ranges, special strings for phone numbers, etc. Use of constants for coding information, such as a constant USERADMINROLE equals 1 for referring to users with administrator rights. Use of string constants as field names for use in data arrays. Long parameter list. More than 3 or 4 parameters for a method. Data clumps. Sometimes different parts of the code contain identical groups of variables, such as parameters for connecting to a database. These clumps should be turned into their own classes. The concept of code smells was introduced by Kent Beck and Ward Cunningham during the 1990s, as they were working on the Celsius 3 Chrysler Comprehensive Compensation Payroll project at Chrysler Corporation. The term smell was used metaphorically to refer to any indication of a problem in the code, similar to how an unpleasant smell alerts us to a potential issue in the real world. However, it was Martin Fowler, a renowned software engineer and author, who popularized the term and brought it to the attention of the broader software development community. In his seminal book Refactoring, Improving the Design of Existing Code, co-authored with Kent Beck, John Brandt, William Opdyke, Don Roberts, and Eric Gamma, published in 1999, Fowler dedicated a section to code smells. Fowler's book described various common signs or symptoms in code that suggest potential design problems or violations of good programming principles. These smells signaled the need for code improvement and had provided corresponding refactoring techniques to address them without changing the external behavior. Since then, code smells have become an essential part of the software development lexicon. They serve as a valuable tool for developers to identify and improve problematic areas in their codebases, leading to more maintainable and robust software systems. Today, the concept of code smells remains a fundamental aspect of the agile software development approach, emphasizing the importance of continuous improvement and clean code practices. Understanding code smells is of paramount importance for every software developer because it directly impacts the quality, maintainability, and longevity of a software project. Here are some key reasons why knowing about code smells is crucial. 1. Improve code quality. Code smells act as early warning signs of potential issues in our codebase. Identifying and addressing them allows us to write cleaner, more efficient, and error-free code. This, in turn, enhances the overall quality of the software, making it easier to understand, modify, and extend. To enhance maintainability, code smells often indicate areas that are difficult to maintain due to their complexity, tight coupling, or redundancy. By refactoring these smells, we improve the code structure and organization, making it easier for developers to maintain and update the software as requirements change. 3. Reduce technical debt. Ignoring code smells may lead to a buildup of technical debt. Technical debt refers to the extra effort required to fix problems and improve the codebase later on. By proactively addressing code smells, we prevent technical debt from accumulating and ensure a more sustainable development process. 4. Facilitating collaboration. Clean code with minimal code smells is easier to understand, which is crucial in a collaborative development environment. When team members can quickly grasp each other's code, communication becomes smoother and collective productivity increases. Understanding code smells is of paramount importance for every software developer because it directly impacts the quality, maintainability, and longevity of a software project. Here are some key reasons why knowing about code smells is crucial. 1. Agile development benefits. In agile development methodologies, the ability to respond quickly to changes in requirements is vital. Code smells, if left unattended, can hinder this agility. Recognizing and refactoring code smells enables developers to embrace change confidently and deliver high-quality software incrementally. 2. Better testing and debugging. Code smells often result in complicated and tightly coupled code, making testing and debugging more challenging. Addressing code smells improves testability and enables more effective debugging, leading to a more reliable software system. 3. Professional growth. Recognizing and resolving code smells is a skill that distinguishes exceptional developers. By honing this ability, developers can elevate their expertise, becoming valuable assets to their teams and organizations. In conclusion, knowing about code smells empowers developers to write cleaner, more maintainable, and robust code. It fosters a culture of continuous improvement, enabling teams to build high-quality software that stands the test of time. Embracing code smells and refactoring is not just a development practice, it is a mindset that reflects a commitment to excellence and professionalism in the world of software engineering. Refactoring is the art of restructuring code to improve its design and maintainability, and it involves several powerful techniques to achieve these goals. In this text, we'll compare 3 essential refactoring techniques: encapsulation, inheritance, and composition. Encapsulation is a fundamental object-oriented programming (OOP) concept that promotes data hiding and information protection. It involves bundling data, attributes, and methods of functions that operate on the data within a single unit, known as a class. By doing so, the class's internal details are hidden from external access, providing a clear interface for interactions with the class. Refactoring with encapsulation focuses on making code more modular, reducing dependencies, and improving code readability. It allows us to change the internal implementation of a class without affecting other parts of the code that use the class, ensuring a higher degree of flexibility and maintainability. Inheritance is another critical OOP principle that enables a class, the child class, to inherit properties and behaviors from another class, the parent class. It promotes code reuse and allows us to create specialized classes that add or modify functionality while inheriting the common aspects from their parent. When refactoring using inheritance, we can extract shared functionality from multiple classes into a common base class, eliminating duplicate code and creating a more hierarchical and organized code structure. However, care should be taken to avoid deep inheritance hierarchies, as they can lead to inflexible and hard-to-maintain code. Composition is an alternative to inheritance, focusing on building objects by combining multiple smaller object components rather than inheriting from a common base class. This approach promotes flexible and loosely coupled code, as objects can be composed of different components, and these components can be easily replaced or modified. Refactoring with composition involves breaking down complex classes into smaller, more manageable components and assembling them to create the desired functionality. This technique enhances code readability, reusability, and testability, as well as making it easier to adapt to changing requirements. In summary, refactoring involves various techniques to enhance code quality and maintainability. Encapsulation promotes data protection and modularity, Inheritance enables code reuse and specialization, while composition fosters flexible and modular code design. Each technique has its strengths and use cases, and skilled developers employ a combination of these techniques judiciously to create well-structured, maintainable, and adaptable codebases. Understanding these refactoring techniques empowers developers to make informed decisions and continuously improve the quality of their code. Refactoring has become an integral part of modern software development practices, enabling developers to improve code quality and maintainability. To support developers in this endeavor, various tool providers have emerged, offering powerful tools and features to facilitate the refactoring process. One notable example is JetBrains, a leading software development company renowned for its integrated development environment, IDEs. JetBrains offers robust refactoring support in its IDEs, such as IntelliJ IDEA for Java, PyCharm for Python, and ReSharper for NET languages. These tools provide a wide array of automated refactoring options, making it effortless for developers to apply various code improvements, from simple renamings to more complex restructuring operations. JetBrains IDEs also include intelligent code analysis, which detects potential code smells and suggests appropriate refactoring actions. Another significant player in the refactoring tool landscape is Microsoft. With their Visual Studio IDE and Visual Studio Code Editor, Microsoft provides extensive support for refactoring in multiple programming languages. Visual Studio offers a range of refactoring options, including extract method, rename, and extract interface, among others, making it easier for developers to enhance code quality and maintainability. Visual Studio Code, on the other hand, provides numerous extensions contributed by the community, expanding the refactoring capabilities to different languages and frameworks. These tool providers not only offer refactoring features but also support developers with various productivity tools, code analyzers, and integrations with version control systems. They play a vital role in empowering developers to deliver high-quality code efficiently, promoting best practices, and reducing the risk of introducing bugs or technical debt during the development process. The refactoring process is a disciplined approach to improving the design and structure of code without changing its external behavior. It involves a series of small, incremental changes that aim to eliminate code smells, enhance readability, and increase maintainability. The process typically starts with identifying areas of the codebase that exhibit signs of potential problems, such as duplication, complex logic, or tight coupling. These issues are referred to as code smells and act as indicators for potential refactoring opportunities. Once code smells are identified, developers apply various refactoring techniques to address them. This may involve breaking down large methods into smaller ones, extracting reusable components, or reorganizing class hierarchies. Each refactoring step is carefully tested to ensure that the code continues to function correctly after the changes. The refactoring process is iterative, and developers continuously repeat the steps, continually improving the code's design and maintainability. By embracing refactoring as an integral part of development, teams can reduce technical debt, adapt to changing requirements more easily, and create a more sustainable and efficient codebase. Let's discuss the types of code smells. 1. Bloaters. Bloaters are code smells that manifest as large, complex, and unwieldy pieces of code that tend to slow down development and increase the chances of bugs. In this section, we'll identify some common bloaters like long methods, large classes, and primitive obsession. We'll discuss how these issues can be detrimental to our codebase and explore strategies for refactoring them into more manageable, concise, and modular code. Object orientation abusers. Object-oriented programming is a powerful paradigm when used correctly. However, object orientation abusers are code smells that indicate an improper application of OOP principles. Examples of such smells include inappropriate intimacy, refuse bequest, and God objects. We'll delve into the symptoms of these issues and demonstrate how refactoring can lead to better encapsulation, inheritance, and polymorphism, resulting in a more robust and maintainable codebase. 3. Change preventers. Change preventers are code smells that make it challenging to modify or extend the code without introducing bugs or unintended consequences. These smells include divergent change, shotgun surgery, and feature envy. We'll uncover the reasons behind these smells and explore refactoring techniques that decouple code, allowing for more straightforward modifications and enhanced flexibility. 4. Dispensables. Dispensables are code smells that indicate the presence of unnecessary or redundant code. Dead code, duplicate code, and lazy class are typical examples of such smells. We'll discuss the impact of dispensables on code maintainability and ways to refactor them out of our codebase, ensuring a cleaner, leaner, and more efficient application. 5. Couplers. Code smells in the couplers category refer to excessive dependencies between classes and modules, leading to tightly coupled code. These smells include feature envy, message chains, and middleman. We'll explore the dangers of tightly coupled code and the benefits of refactoring towards a more loosely coupled architecture, enhancing code reusability and testability. In conclusion, I sincerely hope you found this video helpful and informative. If you have any questions or need further resources, feel free to check the comments section below, where you'll find valuable links to additional information. If there's a specific topic you're interested in and would like to see covered in another video, don't hesitate to let me know. Your feedback and suggestions are essential in shaping future content, and I'm always eager to explore new subjects that cater to your interests. Thank you for being a part of our community, and don't forget to subscribe for more exciting content on the horizon. Happy coding! IT Experts Europe is open IT positions each week. Do not hesitate to contact me to help you finding your dream IT job.